Hey everyone, welcome back to that series of IoT training. So today we are going to discuss about Kinetic EFM. I would like to do an introduction to the software and to the architecture behind this. So my name is Johan Arens. I'm a network designer at Cisco Systems. So just let's get started with an agenda. So we are going to cover today why Cisco, what is the edge computing, what are the needs for IoT, what are the use cases we see with the fog computing. I would like to grasp why it makes sense to do a fog computing and in which cases it makes the most sense. I would like to do an overview of Kinetic, and it's going to be just an overview. The technical videos are going to come later, and then we're going to finish with a summary. So let's get started. Now, why Cisco in IoT? And actually, it all started with a cat. And someone asked back in the circa of the 80s, oh, by the way, did you feed the cat? And that was actually a communication problem. And if you remember, back in the days, we had pretty much no standards. So we have a lot of systems, incompatible systems, so we had a lot of challenges for the communication. So TCP/IP was emerging. That wasn't a standard, but the network topology were not standardized, or that they were proprietary. So as an example, some of them were with token rings, some of them were with Ethernet or serial, or something else actually. And but well, basically, if we wanted to communicate with each other, we had some kind of problem. So someone said, okay, that actually the husband said, okay, I'm going to fix this problem, and he invented the router. And the router is just a piece of equipment, like, you know, we can take an IP packet from one topology and to put that same packet on a different topology. So as an example, the left and right system was with token ring, and the right hand side equipment was with Ethernet. So the packets can come from left to the right. This is transferred for the end user perspective. But it actually didn't stop over there, like, you know, because that individual actually created a company to commercialize that idea, and that company started as Cisco. So it's actually the story behind this. So at the same time, that on top of the router is actually he created an end-to-end as our network. So we called it the data network. And later on we said, okay, well, can we combine voice with data? And yeah, it actually became voice over IP. And then we came out with the idea, can we combine storage with the data network? And yeah, we've done it, and we called it FCOE and iSCSI. And well, quite recently we said, okay, why not combining IoT sensors with the data network? And we came out with the idea with Cisco Kinetic and the architecture behind this. So what are the benefits on this? So we can access data everywhere. We can consolidate an infrastructure, and I'm going to show you how we do this. And then we can mitigate security risk. So back in this, why Cisco, and still why Cisco? Well, actually in our DNA, Cisco is connecting the unconnected. This is our DNA. This is our meant to live. So this is we've been doing this for over 30 years. So, and actually here, this is a market share from IDC, and the marketscape from IDC are for the IoT platform, and this is how IDC is seeing us. So we are in the leader in this market. So this is IDC or IDC Vision. So So just to move forward, with IoT platform, you're gonna hear a lot of edge computing and fog computing, and actually this is the same thing. Both are actually synonyms. So in some cases, even at Cisco, you're gonna hear from edge computing, and some of them are going to call it fog computing. You're gonna hear as well from the Open Fog Consortium, and actually this is an initiative. Cisco is a contributor, so this is the way to standardize the fog initiative actually. So why do we do the fog computing, and why it makes sense? And here this is actually three different verticals where it makes sense to have fog computing and to have the ability to treat data locally. So the first example is from the oil and gas vertical, and actually in many situations they have drilling platform offshore, and the problem with this is that the backhaul connectivity is satellite, and the satellite has two problems. Number one, a terrible latency. Number two, very little bandwidth. So we cannot connect or read a lot of sensors from the platform, and to ship all that data to the data center somewhere on the land, and to get back the answer and to say whatever we need to do. First off, the latency is terrible, so we are going to have operational problems, and then the bandwidth is way too limited, so meaning we need to treat the data locally. So we need to have a tiered data evaluation, and I'm going to show you what it is in the next slides. For the roadways, we have a lot of road signs, just as we can see here in the small picture. So we have most of them are piloted remotely, but this is a manual process, so there was nothing automatically. There was nothing automatic, and some of them are programmed manually. So someone has to drive by and to use a remote control, and then put that specific message in this. This is very manual. So by using this, we could place active equipment, and then to take to read sensor, to take local decision, and to adjust the road signs immediately. So as an example, we have icy road detected, so we can adjust the speed or to send some messages to the drivers. So we need to do the local data evaluation. This is much quicker. In the factories though, so the thing is with the factories, we have a lot of legacy system, a lot of legacy protocols, so we cannot replace all of this with something much modern. So this is just the situation as it is. We need to take this into consideration, and there was no security at all. So most of the time those equipments are connected to our isolated network. Back in the days that was sufficient for a security perspective. Nowadays it's not. So those networks are becoming targets to malware. So we need to take this into consideration, and we need to put some security, and Kinetic can help to do this. So second problem, we have actually high data volume collected from the machine, so we need to do this, and most of the time the plants are most of the time the plants are installed close to the natural resources, so the connectivity is poor or very limited. And on top of this, the operation team don't want to teams don't want to rely on telecom links to operate, so they need to do some local treatment. So if not, this is going to affect the operation of the plant. So at the end of the day, we need to have local data normalization, because there was various of legacy systems, so we need to format the data the same, and we need to structure the data so the data can be consumed by anyone else in the factory or in the organization. So we need to store that data, and then we need to process the data. So I'm going to show you, and I'm going to explain this all of details. Okay, so if we move a little bit away from those verticals, so if we look at the typical use cases where it makes sense to use Kinetic or to use the fog computing approach. So number one is the data reduction. So we have way too much data. We need to treat it locally, or we need to do some data filtering. So it's going to help reducing the data. So we need to be able to treat data locally. So we need to take a decision locally in the network equipment. So the latency is going to be immediate versus taking in some occasion or almost a second. So we need to do some partitioning. So by this, what I mean is, we need to make sure there was no workload that is cannibalizing the resources from another workload. So we need to do this to make sure the resources are well partitioned. So we need to do some application simplification by data normalization. So when we are reading data from Modbus or for Profinet or for BACnet, whatever else, all those are using data structure, very different data structure. So we need to extract the data from those data structure and to put this in a common, in the same format. So so we could send the data to data analyst or to an AI or artificial intelligence. If this is not done, though, the data analyst or the AI cannot do anything with the data. So this is very key. So we need to be able to be dynamic. So I can tell you, as soon as we will collect a lot of data, so the new ideas are going to fuse, and people are going to have a lot of ideas how we can do this and do that. We could do a dashboard about this, a KPI about that, and then we need to be able to be very flexible and to react to the demand very quickly. So this is what we need to do, and this is what we can do with Kinetic. So date time stampings, this is really important. The thing is, the situation is, in some with those legacy systems, a lot of those equipment don't even have a clock, or if they do have a clock, they are not using NTP for standardizing the time, the time to make sure the system is up to date with the timing and stuff like that. So this is a problem. A second problem, we need to timestamp everything that is coming in the system. So if there was no timestamping, the data correlation cannot be done. If we want to use AI or to use the services from data analyst, we absolutely need to timestamp the data. This is very, very important. So as an example, if I'm reading a temperature on a sensor, and on a different sensor I'm reading humidity, if I want to correlate both, I need to have a timestamp on both data. So I can relate, okay, some event has happened at some point, so we had that temperature, we had that humidity at that point of time. So this is really important. So now we're gonna have an overview about Kinetic, and actually we are using Kinetic as a generic term, and Kinetic, it is actually a family of products. So we have Kinetic GMM, we have Kinetic EFM, we have Kinetic DCM, and all the three are different products. So in the last video I was talking about GMM. If you didn't have the chance to watch that video, go ahead and go to YouTube and to watch it. Everything you need to know is covered in that specific video. So today we are talking about EFM. So this is the module from the middle. and in the next videos I'm going to talk about DCM, the data control module. So where is EFM fitting in the model? So as an example, a GMM is fitting in the green area over here. So this is the area that is sitting on top of the sensors. So it could be GMAD, but it could be IE switches, or it is one or the other, actually, to provide the connectivity and the connectivity. And EFM is playing in the orange zone. So the first thing we're going to do is the data extraction. The data extraction is actually the way to talk to the sensors over here, to talk their protocol. As an example, if that piece of equipment is using Modbus, I need to talk Modbus from this point to extract the data. So the data extraction could be done with links in Kinetic. And a link is actually a piece of a module. This is a piece of software. So by default, we are shipping Kinetic with over 50 different links, so different various protocols. And if the protocol you need to use is not listed in those 50, actually this is modular. So there is a huge open source community out there on the internet. I'm going to provide you the links, and those folks are actually creating the links actually. And if a protocol is not shipped today, it's going to be shipped in the next iteration of the product, or you can go ahead and go to that community to grab that piece of software and to activate it in your EFM installation. So it's going to talk that protocol. If you need to talk and to extract data from an in-house software or an in-house machine, actually you can even create your own links, and actually we have templates to help you with this. We have developer communities on our DevNet site to help you putting together your own link, and then we can instantiate the link, and it's going to present the data to the next layers. So once the data extraction is done, so actually the data is still raw, but it's available for treatment in EFM, and we are going to use the edge and fog processing to do this. So we are going to grab that data, and then we are going to extract it, to format the data, and to structure the data is going to be placed in columns, in tables. So as an example, we could have a row with a column with the data, the timestamp. Then we have the value of the data 1, data 2, data 3. It depends, but it could be various data, various piece of information that is in the same row. But the structure is up to you, but it's going to be in the table. So once it's in the table, I can do some real-time visualization. I can do some real-time analysis of the data. As an example, I'm reading a temperature. If the temperature is above 20 Celsius, I can do an action. It's below 20 Celsius, I can do another action, and so far and so on. So it could be this. And here with the visualization, you can actually create comparing KPIs, dashboards for KPIs, graphs, and all those stuff can be done with the visualization. Once the visualization that layer is done, we can send the data to the data control policy. So we are going to segment the data and to put some ownerships on some piece of data. So some piece of data can be only accessible from one group, and some other piece of data can be accessible from another group. So this is what we can do with this. And then we can move the data to your own application, or to your own cloud, or to IBM Watson, or to your Microsoft Azure or Google AI, that kind of stuff. So the filtering can be done over here, and we are talking about layer 7 filtering, because we are filtering based on the value of the data. All right, so this is something we can do. So to give you an idea of of the architecture of a system. So we have a simple network over here. So we have on left hand side we have a few sensors, PLC things. Actually, we are going to provide the connectivity with a switch or with a gateway. And here in that example, this is let's pretend this is just a switch. So we provide the basic connectivity. In that switch, we are going to deploy one instance of EFM, and that thing is going to be activate a link to talk to those equipment on the left hand side. So those equipment we are going to talk Modbus for as an example, and then we are going to extract the data from this, and then we are going to normalize a little bit the data. Okay. When it's done, the first action you could do, you could send that piece of data to your own application. It could be a SQL server, it could be an OSI soft Pi, it could be whatever it might be. Actually, this is up to you. Or we can actually send the data to an additional instance of EFM. So we can have a tiered system. So let's say this is here at the plant level. So we are going to send the data for visualization, to create dashboards and to display our KPIs. As an example, this line, assembly line, is stopped or has processed that many parts per hour, that kind of stuff. And then we can collect that data and to present the data to the data center. So we can do some storage, we can do some systemic dashboard for the leadership team. As an example, they want to see whatever is happening in whole plants, so to have some metrics, some KPIs. So this is how we can do it. So from all those points, we can as well send the data to your own application, so you are not stuck in one way or the other. So this is up to you. This is very flexible. And actually the piece you're running here and here, this is actually the same code. And over here there was this is the same code, but the visualization is not available due to the lack of resources on those equipment. So then we can use DCM to send the data to help you to do the partitioning of the data and to send the data to a cloud. And this piece is actually done in a cloud, and I'm going to cover this in upcoming videos. So, and of course the GMM module can help you to manage the gateway if you have installed gateways to do the connectivity and the data extraction. So actually, what are the strengths of EFM? And actually, keep in mind, this is a real-time processing unit. So we are taking data real-time, and then we are analyzing the data real-time, and we take a decision real-time. And that piece of software has been optimized to do this and to provide the response time you need to your projects. And then we have the distributed service architecture. This is the way actually all the tiers are bound together. So this is encrypted. So this is a secure way to do the connectivity. And then from this we can use DQL, so the data query language, as an example, to grab the data from any point of the data fabric. So as an example, from this instance in the data center, I can pull data from the downstream instances, and as an example, I could grab all the temperature, whatever they might be. So in one query language, I can grab the data from everywhere. Then we have the protocol connectors. This is the link I was talking about. This is modular, and therefore this is very flexible to help you to add some new capabilities to your EFM, whatever it might be. Then we have the path stream, the path stream database. This is a historian. This is a high-speed database. So this has been optimized for inserting data and to grab data to create dashboard, and to allow you to very quickly extract data for future treatment. Then we have the the dashboard editor. So this is the visual data policy editor. So this is the way we're going to present data and to help you to put together some compelling dashboards. And then we have the system monitoring and configuration. That piece is responsible for monitoring all the system, all the components, all the tiers, to make sure everything is operating as it's supposed to. So to give you an idea for two use cases, one for factory and one for roadways. The first one on the left hand side is for factory level. So this is three layers. So the number one, we are going to deploy EFM instance on the IE switches. So on top of providing the layer 2 connectivity, those equipment are going to run the software. So it's going to talk Modbus, Profinet, or whatever it might be, to talk to the things that are in the layer below, to extract the data. Normalize the data is going to be done at that layer, eventually to take some local decision, and then we are going to send the data to the next layer at the factory level. So here in this example, this organization has multiple factories, so and each factory has one instance of EFM. So we are sending the data to the factory tier, and then from this point we can do some visualization. As an example, a line could be could have its own KPIs, its own dashboard. So we have processed X thousands of raw material per seconds, per minutes, or whatever it might be, or the line uptime is this, line without interruption is that amount. This kind of thing we can do, and then we can send the data to the enterprise layer. This is where we are going to collect data and to create dashboards, as an example, for the leadership team, and they can build some systemic overview of the organization with all the factories and all their performance, that kind of stuff. So this is how we can do this. So we can do many things, and this is just simple examples. So a second example regarding roadways. So on the first layer, we have actually the road signs and the vehicles and the data generated by the vehicles and the various sensors on the roadside. So on the roadside, we are going to put the infrastructure is going to be gateways running EFM, and as an example, we could read some temperature sensors placed in the road. So as an example, we can detect, oh, by the way, this is close to ever freezing point. So we can actually display a message on the road sign saying, okay, risk of icy road, slow down, or speed limited to 50 kilometers per hour, that kind of example. So the decision can be done very immediately versus asking someone to do it. So this is much faster. And as an example, if there is a car wreck, so we need to advertise this as soon as possible as it is detected. So this could be done very quickly. So of course the data is sent over the control center on the layer on top. So this is two-layer system. So and those guys, they have their dashboard and they can take action and to override a decision made by the EFM instance over here, for as an example. But this is something we can do. This is a two-layer system. So we have many things we can do as well with this. This is not limited with my example, by the way. So just to move forward, to give you an idea how we do things with Kinetic EFM. So the first pages I want to show you is the screen capture on the back over here. So this is the system administrator. This is where we are going to have an overview of the logs of the system, of the links. This is where we can activate links and to import some new links, and all the links management is actually done from this point. Then once a link is activated, we can actually use the data flow editor to grab the data and to create the logic behind this. So each box over here is called a block, and actually we can actually drag and drop the data presented by a link. We can drag and drop in the flow editor, and then this block actually is the data itself. It could be in temperature as an example. So let's pretend this is temperature, and I want to make sure I need to put the right message to my road signs if temperature is below than 2 Celsius degrees as an example. So here in the yellow box over here, I'm going to say this is an if then else block, and I'm going to say, okay, if temperature is lower or equal to 1 degree Celsius, so then send the message, I see roads slow down, and the speed is limited to 60 kilometers per hour as an example to the road signs. And the red block over here, it's going to be the block talking to the road sign actually. Then if I'm getting back to my if then else, in else, if the condition is not true, so I'm going to publish a message to my road sign and say, okay, drive safely. As simple as that. So and then we need to have an overview of how the system is performing, especially as the system is can be very distributed. So the system monitor is responsible for overviewing everything that is happening in the system, so we can have an overview of the KPI of the system and keep KPIs to make sure everything is performing as it should. So there was even a topology, so you have an idea of what is your data fabric real time. So this is a third page, and the fourth component is actually a real-time data visualization, and actually this is optional. The licensing is even optional, so if you already have a visualization software, you don't need to use this one, but this one is very well integrated, and this is real-time as well. So it could as well use the historic values you have stored in your past stream database, but this is optional. Okay, and keep in mind everything is drag and drop, and this is focus on simplicity and is focused on real-time processing. Okay, so just to summarize this video, so Kinetic can help you to extract data. Kinetic EFM to extract data, compute and move data. So this is the bread and butter from EFM actually. But if I can summarize all the strengths of the software and then why it makes sense to use it and the use cases. Number one, if you need to have a distributed compute, and then you need to have compute all over the place, this is a really good fit. If you need to connect a various range of devices or legacy systems to extract and transform data, this is another use case. If you need to respond real time, to apply rules and to treat data real time, this is a good fit. If you need to reduce data before sending to the higher network level, or to process the data locally due to the bandwidth or to the latency issue, you have a really good fit with this. If you need to process data in the industrial environment without depending on the cloud connectivity, or if you have limited access, this is another good fit. If you need to maintain data to a historian, to data for future analysis, to timestamp the data, this is a really good fit. And if you need to have a visualization to create dashboards, KPIs, that kind of thing, this is another good fit. So if you want to move forward with EFM, you want to play with it, so you can go ahead and go to DevNet, and DevNet can help you to actually understand how to do things, and you can even rent for free an EFM instance to play with, so you can get a sandbox over there, so you can, and there was some sensor simulator, so you can use this to understand how the real-time programming is working, how to create dashboard, or to create and to process data. So it's going to be there. There was a community you can use to help you with your questions. So this is This is available over there. There was a YouTube channel from the BU, the business unit. So the link is here. And if you need to use the Kinetic APIs, everything is documented, and the links are over there. So just because I'm a nice person, I'm going to publish the links in the comments of the video, so you don't need to do anything else but clicking on the links. So I hope you find this video interesting. If you did, please go ahead and like it. If you have any comments or things to add or some feedback to give me about the content of the video, don't hesitate to comment in the YouTube comment section. This is always appreciated and reviewed. So hope I'm gonna see you next time. For the next video is gonna be on the flow editor and how to start doing some real-time programming. Take care, have a good day.